The second policy experiment I'm going to consider is a monetary policy experiment. In this, we're going to increase the short-term interest rate by 1 percentage point relative to the baseline solution. However, this creates a problem for us because the short-term interest rate is an endogenous variable in the model rather than an exogenous variable, as was government purchases of goods in the previous example. Well, the first stage is we need to create a new scenario in which we override the short-term interest rate. So I'm going to click on Scenarios here and then create new scenario. That will be scenario 2 by default, and then under overrides I'm going to override RS, the short-term interest rate. Now the problem is, as we said earlier, the short-term interest rate is in fact an endogenous variable here. So to prevent the model overriding my settings for this, I'm going to comment out the short-term interest rate. So put a quotation mark next to the equation for the short-term interest rate, which is given here in the text view of the model, and that will make sure that it ignores that equation when it solves the model. But of course I've got to recompile the model because I've now changed the model's code. So click on compile here and then yes, and it will recompile my model in which the interest rate is now being effectively made exogenous. But before I solve it, I've got to create some values for the interest rate for my solution period. And in fact, because lags occur in the model for the short-term interest rate in several equations, I'm going to have to create exogenous values for it for a period before the model solution as well as the model solution period itself. So first of all, I'm going to reset the sample here to 2013 quarter 1 to 2021 quarter 4, and then I'm going to create exogenous values for the short-term interest rate over the solution period. So I'm going to create a series here which will be RS underscore 2 because this is scenario 2, and that will be RS underscore 0 plus 1. So I'm going to increase the interest rate by 1 percentage point over that period. Now I'm going to reset the sample period back to the solution period now. So I'm going to set sample to 2014 quarter 1 to 2021 quarter 4, and that will now become the default solution period for the model. Now if I click on solve here, we see the active scenario is now scenario 2, which has the higher interest rate, and if I click on OK, it will now start to solve the model under that assumption. We can look at the effects of the monetary policy simulation in the same ways that we used for the fiscal policy simulation. First of all, using the direct eViews commands, we can look at the effects on GDP and inflation of a 1% increase in the short-term interest rate. To do that, we type in the following command: show USY underscore 2, because this is now simulation 2, minus USY underscore 0. And we enter the same thing for inflation, where the definition of inflation is as follows: PC GDP R4 underscore 2. And again, to compare that with the baseline simulation, we type in the same variable name, PC GDP R4 underscore 0. If I now hit return, then this brings up the spreadsheet here, okay, and we can convert that to graphs by looking at view, graph, and then now look at multiple graphs here, and this shows us the effects of a increase in the short-term interest rate. We can see that it's got negative effect on output and also a negative effect on inflation. We can get the same results by looking at the built-in eViews functions. So if we go to proc, then we'll look at the graphs here. We'll go to make graph, and we'll just list the two variables we're interested in: US GDP and US inflation. Then we're going to look at deviations of actual from the baseline solution. So click on OK, and we get the same graphs that we just constructed using the directive use commands.